শুভ সন্ধ্যা। হীরালাল মজুমদার মেমোরিয়াল কলেজের গণিত বিভাগ ও আভ্যন্তরীণ মূল্যায়ন কমিটির দ্বারা আয়োজিত 2 দিনের আন্তর্জালিক আলোচনা চক্রের আজ দ্বিতীয় ও শেষ দিন। আপনারা সকলেই জানেন, তবুও জানাই আজকের বিষয় গণিতের ইতিবৃত্ত, জনপ্রিয় চিন্তাসূত্র। গতকালের মতোই আজও আমরা পেয়েছি আলোচনার জন্য এক স্বনামধন্য ব্যক্তিত্বকে। কিন্তু তার আগে প্রথমেই আমি অনুরোধ করব হীরালাল মেমোরিয়াল কলেজের অধ্যক্ষা ডক্টর সোমা ঘোষ মহাশয়াকে তার মূল্যবান বক্তব্যের জন্য।
ধন্যবাদ সুজাতা। হ্যালো, শুনতে পাচ্ছ? পাওয়া যাচ্ছে?
হ্যাঁ ম্যাডাম, হ্যাঁ শোনা যাচ্ছে, আপনি বলুন।
হ্যাঁ হ্যাঁ। ডক্টর সুজাতা মুখোপাধ্যায়, অসংখ্য ধন্যবাদ। আমি আন্তরিকভাবে স্বাগত জানাই আমাদের আজকের মাননীয় বক্তা মহাশয়কে। I heartily welcome our speaker, Dr. Professor Riaz Ahmed, এবং একটু এই প্রসঙ্গে একটু ছোট্ট পটভূমি করতে আমার খুব ইচ্ছা করছে। আমি প্রথম যোগাযোগ করেছিলাম আমাদের আরেকজন অধ্যাপক ডক্টর রেহানের সূত্র ধরে, এবং ওনার সঙ্গে কথা বলে আমার মনে হয়েছিল যে সুদূর প্রান্তে মধ্যপ্রাচ্যে বসেও আমাদের বক্তা মনে প্রাণে একজন ভারতীয়, এবং ওনার সঙ্গে কথা বলে গণিত সম্বন্ধে ওনার অগাধ পাণ্ডিত্য এবং ধারণার কিছুটা আস্বাদ আমি পেয়েছিলাম। এবং তারপরে আমি আমাদের অঙ্কের অধ্যাপিকা এবং বিভাগীয় প্রধানা ডক্টর লিপিকা মল্লিকের সঙ্গে কথা বলি যে অঙ্ক বা গণিত আমাদের শুধুই ভাবায় যে অত্যন্ত জটিল একটি বিষয়, এবং যারা আমরা কলা বা সমাজবিজ্ঞানের ছাত্রী তারা যতটা পারি অঙ্কের সঙ্গে দূরত্ব রক্ষা করতে সচেষ্ট হই। সেই অঙ্ককে যদি আমাদের চিন্তনে এবং মননের একটু কাছাকাছি এনে ফেলা যায়, তার জন্যই আয়োজন করা হয়েছিল এই আন্তর্জালিকের। গতকাল আমরা এইরকমই প্রাঞ্জল বক্তব্য পেয়েছিলাম, আর আজকেও বক্তার কাছ থেকে অঙ্কের জ্ঞান, অঙ্কের পাঠ, অঙ্কের কাঠামো, অঙ্কের স্পেস, অঙ্কের পরিবর্তন ইত্যাদি সম্বন্ধে এবং সংখ্যা সূত্রের নানান বৈচিত্র্য সম্বন্ধে কিছুটা ধারণা লাভ করব, কিছুটা জ্ঞান লাভ করব, এই প্রত্যাশা করি। এবং আশা করব যে গণিতের মতো জটিল ভাষা, গণিতের মতো জটিল শাস্ত্র এবং যে অগাধ জ্ঞান সমুদ্রে এরা পাড়ি দিয়েছেন, তার একটু ছিটে ফোটাতে আমাদের অবগাহন করবার যাতে সুযোগ ঘটে। আমি আমার বক্তব্য দীর্ঘায়িত করব না। আমি আবার আমাদের কলেজের সকলের তরফ থেকে, সকল অধ্যাপক অধ্যাপিকা, শিক্ষক শিক্ষিকা, আমার শিক্ষা বন্ধু সহযোগী এবং ছাত্রীদের তরফ থেকে প্রফেসর ডক্টর রিয়াজ আহমেদকে আন্তরিক অভিনন্দন এবং স্বাগত জানাই, এবং আজকের এই আন্তর্জালিকের শুভ সূচনা ঘোষণা করি।
অনেক ধন্যবাদ ডক্টর সোমা ঘোষ মহাশয়াকে। এরপর আমি অনুরোধ করব গণিত বিভাগের প্রধানা এবং কলেজের বার্সার ডক্টর লিপিকা মল্লিককে কিছু বলার জন্য।
শুভ সন্ধ্যা। আমি আমাদের প্রিন্সিপাল মহাশয়া ডক্টর সোমা ঘোষ এবং আমাদের স্পিকার যিনি ডক্টর রিয়াজ আহমেদ, আমার অন্যান্য সহকর্মী বৃন্দ ও ছাত্রীদের স্বাগত জানাই। আমি ছোট্ট একটু বক্তব্য রাখি, আরম্ভ করছি। গণিতের সংখ্যাসূচক জটিলতা ও যৌক্তিক সত্তার অনবদ্য মেলবন্ধন। ভৌতবিজ্ঞান, ইঞ্জিনিয়ারিং থেকে শুরু করে সংখ্যাশাস্ত্র ও অন্যান্য অনেক শাস্ত্রেই এর অনায়াস বিচরণ ও অবশ্যম্ভাবী প্রবেশাধিকার। এই সংখ্যাসূচক ও গণিতের নানান ক্রিয়াশীলতা বিপ্লবেরই নামান্তর। বর্তমানে অতিমারী গণিতের চক অ্যান্ড ডাস্টারকে শ্রেণীকক্ষ থেকে বের করে বিশ্ববিখ্যায় পরিণত করেছে দূর সঞ্চালনায় প্রযুক্তির ব্যবহারের মাধ্যমে। অঙ্কের আনাগোনাকে ডিজিটাল মাধ্যমে স্বচ্ছন্দে প্রকাশ ঘটানোর সমস্যা ও সম্ভাবনার বিভিন্ন দিক নিয়ে আলোচনা করবেন ডক্টর রিয়াজ আহমেদ। তার চিন্তার আলোকে আলোকিত হওয়ার প্রত্যাশায় রইলাম। নমস্কার। সুজাতা।
ধন্যবাদ ম্যাডাম। আজকে আমাদের অতিথি ডক্টর রিয়াজ আহমেদ। ধন্যবাদ দিদি। আজকে আমাদের অতিথি ডক্টর রিয়াজ আহমেদকে আবারও স্বাগত জানাই। ডক্টর আহমেদের 30 বছরের কর্মজীবনের উপাখ্যান বলা সহজ নয়, তবু সারসংক্ষেপে বলি। 1977 সালে ডক্টর আহমেদ তার স্নাতক ডিগ্রি লাভ করেছেন গণিতে সাম্মানিক নিয়ে। এরপর 1980 সালে তিনি স্নাতকোত্তর করেছেন গণিত নিয়ে বর্ধমান বিশ্ববিদ্যালয় থেকে। 2003 সালে তিনি পিএইচডি করেছেন মগধ বিশ্ববিদ্যালয় থেকে। 1983 থেকে 1991 তিনি তার কর্মজীবন শুরু করেন কামারহাটি হাই স্কুল থেকে। 1991 থেকে 1993 তিনি সিনিয়র গণিতের অধ্যাপক হিসেবে যোগদান করেন ইসলামিয়া ইংলিশ স্কুল আবুধাবিতে। 1993 থেকে 1999 এবং ইউনিভার্সিটি অফ সায়েন্স অ্যান্ড টেকনোলজিতে পড়িয়েছেন 2006 থেকে 2017 পর্যন্ত, এবং এখানেই পরবর্তীকালে তিনি ছিলেন ডাইরেক্টর অফ ইনস্টিটিউশনাল রিসার্চ। এছাড়াও SZBAIST দুবাইয়ে, আল গরের ইউনিভার্সিটি দুবাই, HBMSU দুবাই এবং মণিপাল ইউনিভার্সিটি এবং এমিরেটস কলেজ অফ টেকনোলজি আবুধাবির সাথে তিনি জড়িত আছেন। এগুলো ছাড়াও ডক্টর আহমেদ অনেক সামাজিক কাজে নিযুক্ত আছেন, যেমন ছাত্রছাত্রীদের যোগ্য পড়াশোনা ও ভবিষ্যৎ নির্বাচনের প্রশিক্ষণ তিনি দিয়ে থাকেন। তিনি ফরোগে ম্যাথ এবং সায়েন্স কমিটির চেয়ারম্যান। দেশে বিদেশে গণিতের প্রায় বেশিরভাগ নামী কমিটিতেই তিনি আছেন সদস্য বা চেয়ারম্যান হিসেবে। এমন একজন বক্তাকে পেয়ে আমরা খুবই খুশি। আমি অনুরোধ করব ডক্টর রিয়াজ আহমেদকে এবার তার বক্তব্য বলার জন্য।
Thank you very much, Dr. Sujata Mukhopadhyay and Dr. Soma Ghosh, with whom, as she mentioned, I talked to her almost 1.5 months ago through Dr. Rehan, which is actually my, you can say, very close to me. He is friend of my father. He is friend of my cousin brother's son. So this is the way I come in contact with Dr. Soma Ghosh. At that time, as she mentioned, we discussed a lot of things, and she asked me to do this job if I'm asked to. At the same time, I already agreed that I will surely do if I'm given to, because the Kamarati and the place of your college is nearby, from where I actually started my teaching career. I have been doing a lot of other works before, but my teaching career starts from Kamarati High School in 1983. So I am very much, I was very much happy to know that this college is near the Dakshineshwar, from where I used to take my train to Asansol most of the time. I'm really, I feel myself privileged and happy that I am with you. I feel you people are my really friend, philosopher, and guide from all aspects. It is not the case that the one who is of more age is the one who can be the guide. But I feel all of you who are in teaching and teaching professions, they are the actual friend, philosopher, and guide for each and every one, irrespective of the age. So I feel all the faculties over here, I welcome them all. All the faculty over here, the students, and all other math lovers people, I welcome them all in my talk as I was given over here. The most important thing, as Dr. Somagos just now mentioned, that to make mathematics related to the life, this is really very important things. Math has been really hated by most of the child still now, although every people know now that how important mathematics is. In my opinion, mathematics is the life, because it solves all the problems of the life. And also, I feel that the math is life and life is also math, because the whole life is digitalized in terms of the age, time, your childhood, your younghood, your old age. All these are numerically designed in a way that deals with the human life for each and every one. So life cannot be denied to be the mathematics, and mathematics cannot be denied to deal the problem of the life. In my session, whatever I have given to deliver, I will try to do justice with the topic, but I will try to make it more lively, because it is going to be the relation with the life. I'm thankful to the Rehan who introduced me to this college, and I'm thankful to, again, Dr. Somagos, who chose me to this one once again, and I'm thankful also to Dr. Sujata and Dr. Lipika, who gave me chance. I will be now going to start. My lecture will be communication type. I will be happy if you all put your camera on. আর ভালো লাগবে যদি আপনারা সকলেই আপনাদের ক্যামেরা অন করেন, তাহলে আমি একটু কমিউনিকেশন একটু ভালোভাবে হতে পারে। সবাই শুনতে পেরেছেন? হ্যালো হ্যালো হ্যালো, ওয়েলকাম সুপ্রিয়া ভূঁইয়া, অপর্ণা মুখার্জিদা, অরূপ দত্ত. If you put your camera on, then it will be good for me to communicate, to make it more lively. It will not one-sided. So, do you all seeing this slide? Hello? Hello? Hello, everyone.
Yes, sir. Yes, sir. We can see your slide. Please expand it.
Yeah, okay.
Please open your window in a full. Yeah, it's better than earlier.
It's okay?
Yeah, it's fine. Much better than.
Yes.
So you're visible and audible.
Yeah, please, sir.
Okay,
please
thank you
go
very
ahead.
much. Thank you very much. So as you see on the screen, that I have been given the topic Ganiter Itibrukto, Jonopriyata, and Chintar Sutra. So which I have translated this way: Genesis of Mathematics and Popularity of the Principle of Thought Process. I will try to speak time and again in Bengali and English. It will be a blended type of lectures, and I will be trying to most communicate with you. So this is what we are going to start. My name, as you know, is Riaz Ahmed. Are you aware the meaning of Riaz? Anybody of you? I will tell you. The meaning of Riaz in Urdu is mathematics, Riaziyat. So for me, this subject is God gifted, that my name is Riaz and I'm teaching Riyaziyat. This is not a coincidence with many people, but I'm lucky enough to say that my name is giving my profession, which is not available to many people on the board. You can see the many people, the name is the Manush, and in fact, by character and charitro, he is not Manush at all. So this is why I say I thank to my God and thank to my father who gave me this name. I'm very happy to this one. So for me, as I mentioned, the mathematics is life and life is mathematics. So I will try to give you its example from each and every walk of life. So I will ask you a question, you people try to answer me, and then only it will be more better, okay? So my first question is, how many of you have not taken mathematics in high school? I think everyone, right? Everyone. But how many of you have taken Urdu in high school? May not be. If I ask the same question to the people who is knowing Urdu Bhasha Bhashi, they will say, I have not taken. So what is my conclusion to this is that each and every human being has to learn mathematics from every part of the world. What we speak through languages, the same word may give different meaning from one place to another place. Like for example, if you speak the number 20 as Kudi to the Punjabi people, he will not be happy to listen that. But for a Bengali, this is a very normal. But if you talk A plus B whole square to the people of any walk of life, any country, anywhere, you will find everybody understand the same message as it is designated to give. Everybody understand very carefully, very, very clearly that A plus B whole square means what. So what my conclusion is that the mathematics is the universal subject. Wherever you go, nobody can be considered to be qualified. He is not done at least school level schoolings, and every schooling needs mathematics. So mathematics is universal language. So if you want to be called as educated, mathematics is a must. Now, as I told you before, just try to understand the beauty of mathematics, which we are doing all the time, everywhere. Mathematics is defined to be like this. It's the science that deals with the logic of shapes, quantity, and arrangement, and it is all around us. And it is in everything what we do. And that is why I come to the conclusion that whatever I do is math, then math is our life and life is math. Instead of giving you the detail of this one, I will just try to put you one by one some ideas which is related through our daily life situations. When I joined first time in Kamarhati High School, it was my first coming out from my Asansol to Kamarhati. In Asansol, there is no suburban area train as it is there in from Sialda to Bardhaman, or all the parts of the Kolkata suburban area train is there. So when I first arrived there in Kamarhati, one of my friends took me to the Dakshineswari station, and he's trying to explain me the train which I saw for the first time, the suburban area train. And he told me the train here is very, very fast. It comes and goes and it stops for 5 minutes only. Now, I would like you to tell me about this. His version was that it comes and goes and it stops for 5 minutes only. What was the problem with him, which was purely a mathematical? Because that guy was not having an idea of that 5-minute duration means what. He considered that the coming and going is 5 minutes. So if a person at this age, he doesn't understand mathematics properly, can you think that what he's going to face in his life? So life is math and math is life. Exactly similar way, this kind of person can't be cheated by some people to say that somebody will tell me, wait for me 5 minutes and I will come in 1 hour. So again, if he is not understanding what he's saying, he'll be cheated at every single moment. So mathematics need to be understood, need to be learned, need to be applied with each and every persons. Then I met with one other friend in the train, okay, and he started to tell me about the story of the people over here, because in those areas, people travel without ticket in abundance. Almost majority of the students, even the working people, they don't have monthly pass. They travel without ticket. So he gave me a very good story of one of his friend, and he said that one of my friend was the regular traveling without ticket. Once his wife told me that when you're going to the office, you drop me to Kolkata, and then I will go to my mother's house. Okay, and he should accompany his child also. So, but he tried to do what? He tried to escape that, because he never traveled by buying the ticket. How can he tell his wife that I'm not buying ticket? So he tried to avoid this scenario, but her wife was just adamant to go with him. So he took his wife and his son with him to the railway station, and then he bought ticket for them. So when he entered, he saw that the local train is gone, but he see the Durpalla train one was coming. He entered into this, and then there was crowded over there. The people were too much crowd in this. So he put his son at the bunker, and he two people managed to sit the down seats. The ticket collector came and asked him that, where is your ticket? Then he shows the ticket collector, his son is keeping the ticket. His son produced the ticket to the ticket collector, and he saw ticket collector see the ticket and become very angry. He said, what is this nonsense? How many people you are? He said, me, my wife, and my son. Then why this ticket is only half ticket? Then he says, look, how did you become ticket collector? You don't know mathematics? He started explaining him that you don't know mathematics. Then he became, how I don't know mathematics? You are 2.5 people and giving me half ticket. Then he explains, what is 1/2? 1/2 is half. So my son is up and me too are below, so it is half. But don't ask me again that what happened to him after this. But what was the problem here? What was the problem? He used his mathematical idea in a different plane. Like we all of us know that in the plane surface, the lines either meet each other or they remain parallel. But if the lines are in different plane, then there is a third possibility that the line may be skewed. So the problem of meeting and being parallel does not arise in the different plane. So what he did, he applied the rule in a different way. This was his mathematical mistake. So you cannot cheat people who knows mathematics this way. So what I'm trying to suggest that the life is related with all sorts of math, and exactly similar way, there is the two school of thoughts. The one school of thought says the mathematics is innate. The another says the mathematics is discovered. Platonic and non-Platonic ideas are called these things. But if I try to think in my own way, I consider that the mathematics is blending of both. I feel and I believe that every human being inherits from the birth some mathematical concept. If you want to test it, then you go to home and take your children. One is of 2 years age, which he doesn't know how to speak properly, and the other 5 years of age, and in front of him, give the bigger one 5 chocolates and the smaller one 2 chocolates. I can tell you that the younger one will not accept. Why? He doesn't know how to speak. But how he can say he will be angry and will throw out his chocolate and showing his dissent or disagreement? Because he has the concept of magnitude. He understands by birth, he has got the idea by birth that quantitatively he has been cheated. So math is inherent, he has inherited mathematical ability by birth. If you give the same guy, if he walks around and give him 5 chocolates to distribute among 5 people, believe me, he will give 1 and 1 to each one. And you can ask easily now, how he knows how to divide. He doesn't know how to speak, cannot tell his grievances, he cannot speak, but he knows how to divide. So this is again an idea which supports the mathematics being innate. Some people say the mathematics start with the human being, or some people, as I said, that it is already before. There are some peoples who believes in God, and there are some who does not believe in God, but both of them understand that the world was created before the human being, or maybe together with the human being. If you look at the air, it has got a good composition of the oxygen, nitrogen, which help the people to survive in this world. It's purely a mathematical idea involved over there. There is the amount of plain land, amount of mountain, amount of river, amount of jungles. All these are in mathematically proven facts. Also, the planets, stars, all these are following some sorts of mathematical rules. So before the human being, the world was created, it was having all mathematical sorts of ideas there. People started using them according to their needs. According to their needs, they started using. And as the need starts, so the mathematics keep growing. And all history is talking about these things. If you go to the history of mathematics, we will be knowing about how mathematics has been growing up. So there is some kinds of things, the prehistory and the post-history, or the time from where the mathematics was regularized and documented to follow some rules. So these are a journey, okay, and then finally we are coming over here. So mathematics, what we learn in school, in fact, doesn't do justice with the field of mathematics, because we only get a glimpse of one corner of it, but we don't go in detail. So we will be trying to go a bit of detail in it. But again, I will be trying to give you the real life ideas. A child came from the school after the exam. Then his father asked him, "Hey, how was your math question paper?" He said, "Dad, question was very stupid." Then he asked, How it was stupid? They said that there was a question over there, that there is a ladder which is 20 meters high, and in the middle of the ladder, there is a monkey. The monkey does what? In 1 second, he jumped to 1 feet above, and the second he come down half feet down. So if he continues to do this way, then how long it will take to reach the top? Then he said, what is the problem in this question? His father asked. And the child say, Baba, apni janen na, এই যে monkey যদি চায় তাহলে একবারে ওইখান থেকে উপরে চলে যায়। এটা কি যে উপরে নিচে করছে উপর নিচে করছে? তো তোর বাবা বুঝতে পেরেছে যে ওর মেসেজটা কি। কিন্তু what was the real phenomenon in this problem? In this problem, there was a process involved for movement up and down, describing if you try to put with the time, his height, it jumps, you are going to get a smooth curve over there. This is a purely description of mathematical concept. A kind of algorithm is there going up and down. You can program this and you can reach the answer to this one. So then his father said, you are nonsense, you are just stupid, you don't know mathematics at all. Then he says, at your age, I used to be first in my class. Then what was the reply of the son is very important to listen. The reply of the son was that at your age, father, the Rajiv Gandhi became the Prime Minister of India. What you have done? So what is this? What I'm trying to say that if there is a conceptual mistakes, then you are never going to arrive at any decisive result. So the child was in fact not interested in learning. He just wanted to find the excuse to make the thing itself as bad. And this is what we are doing in our life. And this is what says how many people like mathematics, how many people doesn't like mathematics. The idea of putting the question was real life related, but the child was not interested in learning this math. He just wanted to make in hurry and do the things directly. Why we are going to learn all this? But mathematics is not like that. There is a process, there is algorithm, there is a method, there is the techniques, there is calculations and all that, which was missing in the child. He did not realize this one. So when it is exactly similar way, if you go to the prehistory of our mathematics growth, then we can say that the people were as they according to their need, they were learning mathematics. In the beginning of primitive age, there was only 3 types of number descriptions. It was 1, 2, or many. It is still same in some of the language. In Arabic language, there is still 1, 2, and many. Like 1 is singular, 2 is plural. But in our case, 1 and 2 singular, plural. But in Arabic language, 1, 2, and many are not like that. They are 3 different things. So this was the case before in the prehistory area when the people were just knowing this. And they started at that time, the tools of counting, which you can see, there was mark line. There was mark line over here. According to this, they used to use the numbers. Okay. So then we advanced. They gave us the numeral systems. The numeral systems was like a symbolic type where we have 1, 2, 3. You can see all of these over here. So this origin of the earliest civilization, such as the Mesopotamian, Egypt, and Minoan, they goes back to 3,500. They needed to interact with the people like we are doing nowadays. As we say that the one school of thought says that it is growth because of the human being. So interaction of the human being is one of the important criteria for the human relationships. Human relationships. When the people wanted to interact with each other, they wanted to do some trade, they wanted to move, they wanted to know the size, weight, and time ideas. They were in need of this, and they developed all these ones. Thus, these kind of relations are well explained in our mathematics, like there are three different types of relations. One is the one-to-one relation, one-to-many relation, and many-to-one relations. So the relation is a part of our real life, and the mathematics deals with this kind of relation very nicely. Mathematics deals the relation in a very simple way. Like if you have talking about one-to-one, then it is directly relation one person to one person, but there are somewhere where one person have relation with more than one person. But mathematics clearly says if you want to have a good relations, then it should be one-to-one, because it is interconvertible, because there exists an inverse for this type of relations. So the relations are also best dealt with a practical point of view of the human relations. If you want to have a good relations, then it should be one-to-one, because it is interconvertible. There is an inverse. If you like him, he will also like you. But if you are one person like two person, then you may not get the similar kind of response from both of them. So that is a real life scenario. Math is life, and life is math. So it keeps growing like this. Then comes the Babylonian numerals, and they started giving, according to their knowledge, different ways to describe the numerals over here. Okay, then Egyptians numerals, and then Maya numerals, and they developed over there the watch, which is dealing with this kind of representation of the numbers. So mathematics has not grown up just like this way. It has gone through the many kind of developments according to the people's knowledge and interactions and experience and needs. According to the need and necessity, it has been growing. So life was related with the mathematics, and mathematics was growing with the life, and it keeps growing further also. So then come the Greek and Roman numerals, and you know that they used to use these alphabets to represent the numbers. And these are like alpha, beta, gamma. We use in mathematics these things, but actually these were the units used by Greek and Roman in the old age of time. Still they might be using. So these are the way another part of the world in the primitive time, the mathematics were taking its growth so far as the number is concerned. Then come Chinese rod numbers, where they are using the rods to represent the numbers. But this is the first time they use here, brought over here, zero also, there is the space over here. So they were not able to explain very clearly, but they put as a space for zero to be over here. Then they also included the negative numbers, and all of these are coming out of the relations. If you have something, then it is an amount which is 5 or 6. When you lose all of them, then you have nothing. And if you borrow from someone, then you are not having your own. It is for someone. Then the idea of the negative numbers come into being, and Chinese has developed this before. So they have also used the decimal place value system before this. Then you have the Egypt. In Egyptian Babylonian mathematics, they used algebra in a very good way. And algebra, you can say that was like the AB equal to this. We already using this these days now, all of these things, but it has been long developed. First time the concept of unknown was used by these peoples. What are these A and B? This is a general formula. This is true for the numbers with the given domain of values. So here these relations are true for these numbers, but the numbers are unknown. So the first time applied to the other people, they come back to a knowledge where they can use the variable in place of the numerals. So and they have been also working on many ideas like the irrational numbers they introduced for the first time, and then these rational numbers are the 1/13 prime numbers, and then you try to convert them into a more nicer way to understand this. So they have a good here approach. They multiplied by 7 and all that. You can see this easily, which is your which is very easy to understand. Now, first time again, they developed the idea of the quadratic equations. The quadratic equations is very well known. Almost, you can say, some people, I read in one of the articles, more than 100 real life scenario is explained by quadratic equations. Majority of the planetary motions in business, maxima, minima, and all those things are involved in quadratic equation these days. But it was developed long before in this era, Babylonian era. Then we have a lot of. Then there comes the geometrical part of this, and then they develop the geometry also here, where they talk about the length of a circle and area of a disk and approximate. All these has been developed by these people long back in 1800 BC. So here is the triplet of the prime triplet of the Pythagorean triplets. It is seen to be existing long back at their time. Pythagorean triplet is, this very, very important concept, and because of this, you have seen that a to the power n plus b to the power n equal to c to the power was the conjecture. It was recently proved. So it was a challenging thing, but it starts from Pythagorean theorem, as we all know. Then come back the Egyptian mathematics. This again, they have used all these things. They started doing arithmetic, algebra, geometry, everything they started at that time. They used the volume formula for a cylindrical granary diameter d and all that. They have done this one. We are going to come back to the proper way of developing mathematics, which is the birth of mathematics as a deductive science in Greece, Thales, and Pythagoras. So the first time the mathematics start taking its shapes by way of describing rigorous ideas and methods and proofs. So these have been happened in 624 to 546 from this to this BC, and here you can see some geometrical ideas over here. The location of a shape in an oceans. All these where the people nowadays use theodolite, and they are using the concept of the angle by the bearing, and all these has been available before at that time, which we are learning a lot in the chapter of trigonometry these days. The distance and height and the measure of the sides and triangles, all these. So Pythagoras came back. An important development of idea took place in the classical period. Here are the development taken by at the era of the Pythagoras. Principle of the world harmony, which is Pythagorean tuning, music of spheres. This took place at that time. Theory of primes, polygonal numbers, squares and ratio of integers and others, magnitude, irrationality of the square root of 2. All these took place at the Pythagorean era. It took place at the Pythagorean era. Then we go to the important developments of ideas in the classical periods. These are the different periods. These are the different invention by these people of the eras. And we have then we reach to academics, Plato and his circle, Aristotle and his logic. I will be now just trying to skip back and go to. I will ask now. People are patiently listening. I would like to just communicate with you. Dr. Sujata, are you hearing me? Dr. Sujata, are you hearing me?
Yes, sir. Yes, sir. I'm listening to you.
Are you following me? Anything?
Yes, I'm following you, but I'm very weak in mathematics, but I'm trying to grow an interest.
And that is good for you. You have opportunity to learn.
Yes, sir. The historical part is very interesting.
Okay, so Miripanka Das, how are you, brother? Are you here? Madhuri Datto, are you here? Are you here? Actually, I have decided to make mathematics more lively. That was my real program, but it cannot happen without you people coming forward and just respond. Sir, Anjan Das Gupta, sir. How are you, sir? Do you hear me? Ankan Mandal, sir, do you hear me? Okay, so let's go back. Let's go back to now. I will be now just taking one more idea here. So let's go ahead for the Academy of Plato and his circle. These are some of the ideas. Platonists, from where the real mathematical regularizations start. So Plato and Aristotle, these are you can say the founder of making the mathematics in a regular way. Aristotle developed the logical approach for making anything to understand, and mathematics is full of logical ideas. So Aristotle was you can say the father of logical approach for this mathematics. So we then come the golden age of Euclid of Alexandria, where this Euclid of Alexandria is called the father of geometry, and here is the Euclid. He has given 13 volume of the rules and regulations which people are still using, and it is a kind of asset for every mathematicians who want to understand. Euclid considered to be the father of geometry from that perspective. Actually, I will just go back again to ask a simple question with all of you. Okay, can anybody tell me, if I ask you to write the letter A, what do you actually use? What do you actually use? What do you actually use? You use the two lines. You use the two lines, they are meeting at the corner. Suppose if you don't have the idea of the line, how you will make the letter A? Mathematics is much older, much more important than any other subjects. All the letters involve geometrical shapes, which makes you want to make a C, you want to make a G, you want to make a D. All these are the geometrical shapes. So geometry is playing a lot of roles, and the pillar of this has been already stood up, erected by father of geometry, Euclid of Alexandria. So then we started going for the regularization of the mathematics, and then a lot of work has been done over there. Then we go for curves in the Greek geometry. Curve is one of the fantastic. The human life, the graph of the human life, whatever life we have taken, start from birth till the death, it is a continuous decreasing functions. It is representing a continuous decreasing functions, which is nothing but a kind of one-to-one relations, and this is a real idea. It's giving you at what time, how much life you have lost. It doesn't give you how much life you have gained. It actually gives you how much life you have already lost. So this is again a mathematical sense to make your life graph. Every walk of life, what mathematician actually has been trying? They have been trying to explain each and every phenomenon of human being by putting them into a sort of formular equations. But were not capable of doing these things for everyone. Then came into existence of the drawing, the graph, sketches. Then comes the development of when the probability was discovered, then come the idea of forecasting of the data and making some kind of collecting the data, forecasting for the future, or from the small to big, from the sample to populations. All these things were related to life, and these necessitated to develop all these branches of mathematics. Now, mathematics is trying to answer each and every phenomenon of human life, okay, and not only human life. It's all what is happening around us. All the and because of this, in fact, we went to divide mathematics into two big branches, which is your pure mathematics and the other is applied mathematics. The pure mathematics is building the rules and regulation for mathematics to exist. It is regarding pure mathematics, it is said that the mathematician thinks what the things 100 years before, the scientists and others use it after 100 years. So the like, for example, if you can think of the complex numbers. The complex number was first thinking of a people just imagine and get a number. But when the engineering came into being and the electricity and all that came into the pictures, people, the scientists and the physicists found its application in many branch of mathematics. So the development of pure mathematics is continuously going on, and what the pure mathematicians do now, it is sometimes not looking really useful, but it can be useful for the future, where the people are really realizing. A time was just 50 years ago, there was a kind of people who was against to continue with this pure mathematics. There was a long agitation in USA where the people were objecting why to develop all these kind of pure mathematics, but the people did not realize that the discrete mathematics was the one which created the computer itself. So if it has been discrete mathematics and mathematics of the continuous and discrete variables was not developed, then the people have not been knowing, not been able to understand, or not been able to develop the computer itself. I am doing all these things from here and there because within this time I cannot go through, but try to give you a short glimpse of as much I can gain, but I wanted to make it more lively. It didn't happen anyways. So pure mathematics is what we will just try to do a little bit here. So pure mathematics is considered to be the area where the mathematician is trying to do whatever they want according to their curiosity. But as I said to you just now, that later on, like the Boolean algebra, the Boolean algebra is very much used now in logic gate. The people at that time was not understanding the meaning of the Boolean algebra. What is this 1 and 0, 1 and 0? And now all of you understand that the language of the computer itself is 1 and 0. So whatever the pure mathematics is developing, it has its applications, maybe in future, which we must have to understand. We cannot reject any idea which is not practically applicable and understandable at this point of time. It surely and certainly will be useful later on, as we have seen in many cases, as I mentioned to you right now. So here, also, if I remember in my age, when I started, I did my PhD in functional analysis. At that time, in the beginning, like say, for example, 2006, 2007, people were thinking that the number theory is dead. People were we are not ready to learn the number theory. No research was going on. The research started when the cryptography was invented, and then the people now are working day and night on the number theory. A lot of research is going on now on the number theory itself, especially the prime numbers and some beautiful numbers, pi and e, and all these are of a lot of importance for the mathematician and for the other people as well. So the number system, we have here just given a brief. That number system is nowadays explained in this way. There is a heart of the center, natural, whole, integer, ratios. These all of you are aware of. So its structure is the most important here. The structure is given through the algebra. By the way, I would like to tell you that we, being an Indian, we know much more better algebra than the people outside India. The algebra is one of the weakest subject in America, in England. All the peoples, they learn algebra. Their idea of the algebra is very, very weak. When I was teaching the British curriculum privately for my students at that time, come to know their knowledge of algebra is extremely weak, whereas our CBSE curriculum and others are rich in algebra. So Indian peoples are much, much better off in algebra than our other counterpart in other parts of the world. So algebra is the one which is giving you the whole structure, how the numbers will be added, how multiplied, divided, and all these has been given. Then comes this, through this numbers come the one of the most important idea of the present day, combinatorics. This is really fantastic ideas these days. There are probability and statistics use these things a lot, and half of the research, I can say, are especially even nowadays in the engineering, the people are using a statistical approach for doing research, and all these ideas are data and computers are used over there. Then comes the group theory. Group theory is giving you the rules how the numbers will be combined together. Then there come the space. The space here. Look, this is a triangle. This is a triangle. The people still now believe that this whole thing is a triangle. Like this one as a whole is the triangle, but it's a mathematician who only understands that the triangle is just a figure bounded by 3 lines, but this part of the thing is not a part of the triangle. The part of the triangle are these 3 boundary lines. So Pythagoras theorem was applied over here. Through this we developed the trigonometry, and trigonometry is one of the fantastic idea. If there were no trigonometry, there would have been a lot of problem in geometry, especially in the civil engineering. It was going to suffer a lot because of the non-existence of trigonometry. So then comes these days, it's very important, the fractal geometry. Oh my God, this has got a lot of application these days. Every fractals has a full of its explanations in these, in each part. And then comes the bigger geometry, which is your topology, looks at different properties of a space where you are allowed to continuously deform them but not tear or glue them. This topology is topological space, topological idea is extremely important these days. And then comes the measure theory, which is giving you a concept of assignment from one to the other, from one plane to other plane at a time, can be in more than one space. All these are done through the measure theory. Then come the differential geometry, and this is the purely a kind of vector idea involved over here in differential geometry. Vector is a fantastic idea which helps the applied mathematics to grow, and physics is one of the beneficiary for this concept of the vectors. Then come the main important things of the life. Previously, it was the time then people say, you know mathematics. Last 15 to 20 years, the people are asking you, do you know calculus? So now the mathematics is understood and described by calculus alone itself, because this is one of the fantastic development through the concept of the change and its rate. The rate of change is really a fantastic. This is a real concept. This you can say a concept. The rate of change. We develop two important branch of mathematics, which is called integral and differential calculus. So, but then come the dynamic system, where you are using the mechanics, law of mechanics, which is very popular in Newton's law of mechanics, motions and all that you are using. So this is addressing the dynamical system. As I said to you, I'm trying to cover within my time most of the things. And this is another very important concept, which is called the chaos theory, focusing on the study of chaos, studies of when they're in the dynamical system, the chaos is unavoidable. So then for the dynamical system, the chaos theory is coming forward to help and explain many real life phenomena, which is helping to different branch of studies. So complex analysis is again dealing with the complex number and doing a lot of help to in physics and other branches of mathematics. So here is coming now the applied mathematics. It is very difficult to some extent, as I told you right now. Some of the pure mathematical idea is being used in applied mathematics also, but not all of the pure is applied, and not all the applied is pure. You can say that applied, it remains applied, but there are many pure idea which is in fact used in applied mathematics. So this is another very important idea. Like we know that while teaching, we say the number of equations that you can solve is much lesser than the number of equations you don't know how to solve. Number of function that you know how to integrate is very little in compared to the number of function you want to integrate. So there are many functions, many equations that you cannot solve them directly by the pure mathematical ideas. You cannot do analytically what you say here. So analytically, we cannot be able to give rigorous methods for solving a problem. Just for example, if you are using an equation where is the angle and the sine of the angle both is a part of the term of the equations, it's not easy to solve them. It's not easy to solve them. So we need some other types of approach where we can be able to solve the rest of the real life mathematical equations to be able to solve them. So numerical analysis come forward to help to solve those problems very well. All of us know that the calculus explain the idea of the derivative as the limiting concept of the f of x plus h minus fx over h. Now here in through numerical analysis, then we have different approaches, but we have just taken the idea of the h going to 0 by taking the value of h small and small and small, and actually you can see to some extent as we make the h goes to 0, these ideas which is given by the numerical analysis is actually giving almost accurate value. Although numerical analysis is not going to give you the accurate value, so there is a chance of error. And this, from here, we have got the idea of the error. Error theory has already developed over there. The the more or less is the more, if you can minimize the error, we'll apply to the accuracy. But it is also fact that not all the time we need the result to be the accurate. Sometimes we need approximate result. So actually the numerical analysis is actually dealing with the approximate solution for the equations which we are not able to solve analytically. So the game theory is another very important. Game theory is now being used in decision making. At this point of time, as the world is growing very, very fast, everywhere, the people are doing some sort of business. Decision making has become an important tool for every organizer, every manager to know about. So decision theory is necessity of decision theory has developed a game theory where the people make decision according to the well-defined rule. They will be able to make proper decisions. So decision making in business is rampant. Every manager wants to make big decision. Like nowadays, as there is too much of disturbance due to the development of the software in real life scenario. That this disruption caused by these inventions are necessary to be understood and known by the manager, and to make a decision to continue with the present things or introduce the new software, how it is going to cost, will it be beneficial for us, for our business or not. All these things have been coming under consideration through the help of the game theory. So, and above all of us in our life, we are using probability that nobody can refuse to this one. If you ask someone, are you going to come tomorrow? Then the answer will be most likely in probabilistic way. He will say, maybe, possibly I will come 60%, 20%, 50%. So the probability is in every walk of life, and when it becomes a real life phenomenon, it is going to help us to give a prediction for anything to happen or not to happen. Any incident is going to take place or not going to take place. If it is going to take place, what is the chance of occurring? What is the chance of non-occurring? So this is a part and parcel of our daily life, and life is mathematics. Mathematics is life. And then comes the I think I have crossed 5 minutes, just within 5 minutes more I will be wrapping up. And then comes when you are going to take this event to make it random variables, then comes the idea of the probability distribution, which is dealt with in statistics. And this is now a tool for majority of the scientists of economics, business, and nowadays engineers also they are using. So this is, and then is coming with the invention of the matrix concept of the matrix, linear algebra then came as the concept of the discretization of discrete variables. Machine learning came into being, and machine learning is nowadays very, very important because it's dealing with data analysis and many things. So machine learning and cryptography, as I told you, that whole world is suffering because of not having a proper cryptographic locking systems, and mathematicians are coming forward to help the people not to allow any of his system to be hacked or derailed by any enemy, and cryptography is giving a real answer to these things. So, but all these things has got a foundation of mathematics. This is just few part. I will tell you that there must be, to make a mathematical foundation, you must have the rules and ideas which will bind all the development of mathematics. So before I'm ending, I would like to talk about the foundation of mathematics. This area choose to work on properties of mathematics itself and ask what the basis of all rules in mathematics is. Is there a complete set of fundamental rules called axioms, or we call everything as to be a part of the mathematics, which all of mathematics come from, and can we prove that all is consistent with itself? So these ideas, mathematical logic, set theory, and category theory, these are trying to help us, help the mathematician to make it provide a definite rule due to which you can bind them all the mathematical ideas. So this in famous result in mathematical logic, golden incompleteness, this gives our the axioms and the rules for defining the mathematical, giving the mathematical foundations, which means which means that all kinds of things made up by humans, we also have theory of computation that looks at the models of computing and how efficiently they can solve problems, and contains complexity theory that looks at which is and is not computable, and how much memory and time you would need, which for most interesting problems is an insane amount. So here is where I would like to end my discussion, but I will really like to ask you. Yes. So now I will be coming one-to-one. I wanted to make it more lively with you to the communication, but anyway, I tried my best to give my lecture. I wanted to make it more lively through the real life situation. But anyways, I had to go back to the theoretical part. There is Samim Sarkar. Hello? Are you, Dr. Sujata, are you there?
Sir. Yes, sir. Absolutely.
So from my part, I have done my job. If there is any question, anything, so I can be able to answer, or because the time I've already taken more. Sorry for that. It was supposed to be.
যদি কোনো প্রশ্ন থাকে ডক্টর রেয়াজ আহমেদের জন্য একটু চ্যাট বক্সে লিখে জানান, আমি স্যারকে বলে দেবো। কারোর যদি কোনো প্রশ্ন থাকে, if you have any questions, please write in the chat box.
But I will really thank to all that in the mathematics session, so many people join. It's really very great. This shows that how much you love mathematics. আমি তো বলি যে mathematics তোমার শুরু হচ্ছে the time you came into the womb of your mother. Your mathematics start from that time, and it goes even till your death. And according to some people's belief, there is also accountability in the life hereafter. So you cannot escape mathematics. Mathematics is taking account of every bit of your life. I will just give you a very simple example. I'm trying to be nonsensical to bring the sense in this. A person went to the hospital taking his wife to deliver a child. So what happened? It was the real time of delivery. So the guy is outside the delivery room. He is moving, coming forward and backward. He was anxiety, and he was really anxious that his wife, the delivery took place safely. So after 15 minutes, one nurse comes up and tell him, "Congratulations, you got a baby of 5 pounds." That the lady nurse did not tell anything else. She did not tell about her health or the body shape, anything. But this number 5 pounds give enough information, and which make the father of the child to jump and make him happy. So what I'm trying to say is that the mathematics is making sense in real life a lot. We have to just recognize that every single phenomenon of life is due to the mathematics. You cannot explain a single idea, a single concept without having mathematical concept. If you have anything, you can ask me to explain mathematically. I will tell you, because every single thing is having some position, having some magnitude, having some shape, having everything, whether it is a quality or quantity. Nowadays, even beauty is measurable, which is using the mathematical ideas. So what I'm trying to say that the life is mathematics and mathematics is life.
So, sir, thank you very much. When you said that life begins and ends with mathematics, একদম ভালো কথা বলেছেন স্যার, এবং আজকে ধন্যবাদ জ্ঞাপন করছি স্যারকে, ডক্টর রিয়াজ আহমেদকে। এবার আমি অনুরোধ করব আমাদের ইংরেজি বিভাগের প্রধান ডক্টর পৃথা কুন্ডুকে ধন্যবাদ জ্ঞাপন করার জন্য। ডক্টর পৃথা কুন্ডু।
থ্যাংক ইউ শ্রেয়াদি। আমরা এখানে যারা আছি তাদের মধ্যে বেশিরভাগই হয়তো অঙ্কের মানুষ নই, তা সত্ত্বেও আমরা এই সেমিনার অ্যাটেন্ড করলাম, এবং স্যার যে সুন্দরভাবে জীবনে গণিতের প্রয়োজনীয়তার কথা বুঝিয়ে বললেন, তা থেকে আমরা আশা করি সবাই অল্প বিস্তর সমৃদ্ধ হলাম। ডক্টর আহমেদকে আন্তরিক ধন্যবাদ জানাই। আমাদের মাননীয় অধ্যক্ষা মহাশয়া ডক্টর সোমা ঘোষকে এরকম একটি ওয়েবিনারের আয়োজন করার অনুমতি দেবার জন্য অজস্র কৃতজ্ঞতা জানাই। ডক্টর লিপিকা মল্লিক, আমাদের গণিত বিভাগের প্রধান লিপিকাদিকে কৃতজ্ঞতা জানাই এরকম একটি সেমিনারে আমাদের যোগ দেওয়ার সুযোগ করে দেবার জন্য। এছাড়া আমাদের আইকিউএসসি কোঅর্ডিনেটর ডক্টর রূপা সেন, আমাদের সেমিনার কমিটির কনভেনার মিস্টার প্রদীপ্ত মুখার্জি, আমাদের অন্যান্য সহকর্মীরা এবং অন্যান্য কলেজ থেকে বা অন্যান্য শিক্ষা প্রতিষ্ঠান থেকে যারা এখানে এসে যোগ দিয়েছেন, তাদের সকলকে যথাযোগ্য ধন্যবাদ জানাই। আমাদের কারিগরি এবং প্রযুক্তিগত সহায়তায় যারা থাকে সবসময়, পূজা, ত্রেয়ী, তাদের সকলকে ধন্যবাদ জানাই। আমার মনে হয় আমি সংক্ষিপ্ত পরিসরে সকলকে ধন্যবাদ জানাতে পেরেছি। যদি কেউ বাদ থেকে যান তাহলে ক্ষমা করবেন। ধন্যবাদ।
সেমিনারের শেষ ঘোষণা করেন।
সকলকে ধন্যবাদ জানিয়েছো। তো আমরা সকলে মিলে একটা পরিবার, কাজেই একজনের নাম নেওয়া মানে বাকিদেরও নাম উল্লেখ করা। আমাদের কৃতজ্ঞতা, আমাদের ধন্যবাদ বিশেষ করে আমরা দেব ডক্টর পার্থসারথী মুখোপাধ্যায় এবং প্রফেসর ডক্টর রিয়াজ আহমেদকে, যাদের জন্য আমরা এই আন্তর্জালিকটি সাফল্যের সঙ্গে সমাপন করতে পারলাম। আর অবশ্যই তার সঙ্গে আমি ধন্যবাদ দেব আমাদের কেমিস্ট্রি বিভাগের প্রধান ডক্টর অমৃতা ব্যানার্জি, আমাদের সোশিওলজি বিভাগের প্রধান ডক্টর চন্দ্রবলী দত্ত, জার্নালিজমের প্রধান ডক্টর সুজাতা মুখোপাধ্যায় এবং ইংরেজি বিভাগের প্রধান ডক্টর পৃথা কুন্ডুকে, যারা একমাত্র অমৃতা ছাড়া কেউই বিজ্ঞানের লোক নয়, কিন্তু এই বিজ্ঞানের সঙ্গে আমাদের পরিচয় করিয়ে দিতে যারা সাহায্য করলেন। এবং অবশ্যই ডক্টর লিপিকা মল্লিক, যিনি অঙ্ককে আমাদের ঘরের মধ্যে এনে দিলেন। ওভার টু সুজাতা।
আজকে যে অনুষ্ঠানটি হলো তার জন্য সবাইকে আবারও ধন্যবাদ জানাচ্ছি, এবং ম্যাডাম যদি পারমিশন দেন আজকের সবাই এখানে শেষ হবে।
শেষে আমি সবাইকে ধন্যবাদ জানাবো। আমি খুব খুশি হতাম যদি আপনারা একটু বলতেন যে আমি আমার কাজটা ভালোভাবে করতে পেরেছি। I want to listen from Dr. Soma Ghosh. Did I do my job perfectly well or not?
আমি প্রফেসর আহমেদকে বলবো, আমরা সত্যিই আপ্লুত, এবং আপনি প্রথমত আমাদের সময় দেওয়ার জন্য, আর আপনি চ্যাট বক্সে যদি দেখেন আমাদের ওয়েবিনার কমিটির অর্গানাইজার প্রদীপ্ত মুখার্জি বলছে খুব ভালো হয়েছে। অর্থাৎ আমাদের অর্গানাইজার যদি ভালো বলে থাকেন তাহলে সেটা যে সত্যিই ভালো হয়েছে এটা বলার অবকাশ রাখে না।
আমি ওইটাকে লাইভলি করার জন্য চেষ্টা করছিলাম, কিন্তু মানে ইন্টারাকশন না হওয়ারে আমাকে স্টিক টু দা স্লাইড হতে হলো। আমি এরকম কোনোদিনই করি না, আমি লাইভলি কথা বলার আমার অভ্যাস। So আমি
And,
একটু
খুবই আমরা খুবই উপভোগ করেছি এবং খুবই মনোগ্রাহী হয়েছে এবং অন্যান্যদের সঙ্গে আমার কলেজের যেমন ইতিহাসের ডক্টর শ্রেয়সী ঘোষ বা রাষ্ট্রবিজ্ঞানের প্রদীপ্ত মুখার্জি স্যার তারা যখন উপভোগ করেছেন তার মানে আপনি একেবারেই অঙ্ককে আমাদের কাছে এনে ফেলেছেন, এ ব্যাপারে সন্দেহের কোনো অবকাশ নেই।
thank you,
অঙ্কের
thank you.
লোকেরা তো অঙ্ক বুঝবেই, কিন্তু যদি সমাজবিজ্ঞানও বোঝে তাহলে সত্যিই অঙ্ক আমাদের ঘরে এসেছে, এটা বলাতে
আমাকে রেহান একটু ব্রিফ করেছিল, সেই জন্য আমি আমার টপিকটাকে ওই দিকে নিয়ে যাওয়ার চেষ্টা করলাম, যাতে করে লোকে শুধু বসে চুপচাপ বসে না থাকে, কিছু কিছু নিয়ে যায়। তো এই জন্য আমি আমার লেকচারটাকে ওইভাবে ডিজাইন করলাম। বহুত থিওরিটিক্যাল থেকে।
থ্যাংক ইউ স্যার, থ্যাংক ইউ।
Thank
Thank you very much, sir. Thank you very much.
Thank you very much. Thank you. Goodbye, everyone.